Hey, physics. We got some new stuff. Kind of new stuff. Like it's still energy related. These are the chronicles of our adventure into energy so far. We've talked about potential energy and then kinetic energy. I mentioned that heat is a form of mechanical energy. That's like where did the energy get lost, right? Did a quick example with our goose friend the first time, just like calculate how much kinetic does it have, how much potential does it have, what's its total mechanical energy. Then did a little bit of conservation, right? Energy has to be conserved. So if an object like has energy at a certain point and it does something, right? Something happens, it changes its position, it changes its speed. The total amount of energy that object has isn't allowed to change. It can change from one form to another form. It can go into another object from the object that it started in, but it's not allowed to change how much total energy there is, right? So, and I think I had also mentioned, or I had referenced, maybe I didn't, I don't remember exactly what I say out loud and what I don't say out loud anymore, but I'm pretty sure that I had said that energy is kind of like a currency of the universe where if you have some of it, you can do some stuff. If you have a lot of it, you can do a lot of stuff. If you don't have much of it, you can't do much stuff, right? There is another form of energy that I want to mention because I know it's on the reference table, and the reason I didn't bring it up with potential and kinetic is because it doesn't it there's a really big clue. There's a really big like red flag that tells you you have to use a very specific type of energy, right? And oh, I can't go that way. There's force of friction down there. Why is there force of friction down there? Why is that? Again, behind the scenes, like this is all just the same. Like I can zoom way out. Like this is the stuff that we've done this year. That's I don't know what that says. Like that's it. That's all the stuff we've done. This, but I don't. Anyway, I guess I'll go to the right instead of going down. You know what? Why don't I could just move these, I guess. Maybe not. Hello? Sometimes my computer doesn't like to let me move things, but it's fine. Hello? Oh, oh. This all happens in one take, kids. I don't edit this stuff. I could. In the future, I might. Maybe after the break, I'll be a little more elaborate with how I do this stuff. But right now, I want to go down. Is that so much to ask? Just for the record, it clearly is too much to ask. I genuinely don't know why it's not allowing me to move this. What do all these do? What if I ink grab, like, copy, cut, delete? What if I just want to move the thing? Alright, this is... Can I move this one? No? I can't move either of them? Can I? Alright. A little bit of a... Oh, goodness. A little bit of a technical thing happening here. Okay, close. But like I want to just take this whole page and move it. Do I need this? This was... I'll keep it. Alright, fine. We're just going to the right. Sorry, wasted a lot of time there. I'll make it up on the back end. There is a type of energy that, like I said, it's going to be very obvious to know, like, oh, I need to use exactly this type of energy. And the reason you will know I have to use exactly this type of energy is because it's spring... Okay, I thought things were going to move on me there. It's spring potential energy. Okay, nope, that's not a straight line. Like, my desk and my... Okay, there we go. You will know you have to do this because you'll be given information about a spring. That's really it. The spring potential energy, which is labeled as... Oh my goodness. It's all one take. It's all one take. Spring potential energy is potential energy with a subscript s. S for spring, right? And it shows up on your reference table like that. And it is 1/2 times k times x squared. Now k is the spring constant, and again, this is information that they will have to give you, because the spring constant, even though it says it's a spring constant, it's unique to each spring. So every spring has its own spring constant. If it's kind of small, it's very easy to compress or to elongate that spring. If it's big, it's very difficult to compress or stretch that spring. Now x is where it gets a little strange. This is said a little differently on your reference table. I like this definition, personally. It's the displacement from equilibrium. And I like this definition because it's a little simpler than what they have on there. But basically, if I gave you an example, and the example was a block is attached to the wall by a spring with a spring constant k equal to 10 newtons per meter. How much energy is stored in the spring when it is compressed. That's not how you spell compressed. C-O-M-P-R-E-S-S-E-D. Compressed. 0.25 meters. Right. So again, the way that you know you have to use spring constant, or the spring potential energy, they told you at the spring, they give you a spring constant, and then they ask again about the spring. They ask about the energy of the spring. So you'll have clues, right? If you're going to do this, you have the formula. Potential energy of a spring is 1/2 times k times x squared. And that is 1/2 times 10 newtons over a meter times 0.25 meters, and I'm going to square that. Now be careful with your halves and be careful with your squareds. 0.25 squared is 0.625. 0.625 times 10 is 6.25. Half of that is 3.125. And remember, it's potential energy. It's a type of energy, so the unit of measurement is going to be a joule. All right? Now, the other thing about spring potential energy is that they can work it into a conservation of energy question, where they might have told you a block is attached to the wall by a spring with a spring constant of 10 newtons per meter. If the spring is compressed by 0.25 meters, maybe the block isn't attached. The block is no, the block could be attached. So they give you the same information, and then they say you release the block, and instead of simply returning to equilibrium, the block flies off of the spring. If the block has a mass of 1 kilogram, how fast is the block moving when it is released from the spring? Right? It's a weird combination of things to happen. Again, we do it all for physics. But the potential energy that was stored in the spring turns into a different kind of energy as it moves. Right? Once it releases, it's no longer any spring potential energy. It's only kinetic energy, because our object is now moving. Now, you know that the potential energy that's stored in the spring is going to turn into the kinetic energy of the block. So you know that the kinetic energy is going to be 3.125 joules. You know the mass of the block, just told you, is 1 kilogram. So theoretically, you could solve for its velocity, right? You have a different formula for the kinetic energy. If you know how much kinetic energy it has, and you know the mass of the object, you can solve for the velocity. So really, spring potential energy is going to be another thing that you will either outright solve for, or something that you will have enough information about to do a conservation of energy question. Now, what you're going to do in between now and next class is a few more questions with conservation of energy, some examples of spring potential energy, basic stuff. There's one more kind of like loose end in energy to clean up, and we will clean that up next class. All right. I will see y'all next time, right? Know that what I want to do, right? Spring potential energy, second to last thing, we're going to clean up the last loose end on Thursday/Friday, right? On E-Day. And then after E-Day, so sometime on F-Day, your remote F-Day, whichever one it is. If you're group 1, it'll be on day 2. If you're group 2, it'll be on day 1. I want to do another online. I want to do a quick quiz on energy, because I want to do this little baby quiz before the break, so that it's not all gone after the break. All right. So make sure to, again, if you have questions, if you're confused on something, please ask. Otherwise, I will just assume that everything is fine and like move on my merry way. Questions, email also like works. I should be able to respond to those. But this is the second to last cleanup. We'll do the last bit of cleanup on Thursday/Friday. Quiz on Monday or Tuesday, depending on which day is your online day. It'll be on my CBA, just like the momentum one, easy to grade. You'll probably have some short answers this time, so I'm figuring out how to do that. It's very likely that the short... I'll figure it out. The quiz will be up on my CBA Monday and Tuesday. Until next time, I don't know. Stay safe. Be good. I'll see you soon, kids.